Hello, today I'm going to be teaching you about variables and lists. We're going into variables because I had a video recorded for variables, but it was kind of short and it didn't go over some topics I wanted to go over, so I'm going to be recording that with lists as well because they kind of go hand in hand. I will not be going into list variables though, because those get a little complicated as you can't sync them and they're only localized. That's about it. And I will be teaching you just one example. I'm going to be teaching you what every chip does, almost every chip. I'm not going to go into every chip, but I'm going to go over most chips. And then I'm going to give you one example of how you can use it in your logic circuits, and that's about it. Like I said, my videos are for about teaching you what chips do in case you don't understand it, and you go out and you figure it out on your own, because I believe the best teacher is yourself. You know, everyone learns their own way, and because you have your own way of teaching, you can teach yourself. I just help you along that path. If you have any questions, you can always ask me. I'm always here to help. I do have a class if you want to take it, but I believe you can do this on your own. Everyone can. You just need to put the work into it. Let's go into our first variable example and get into it. Alright, so here's our first example. We are looking at the Boolean variable first, as this variable is used quite a bit, and it helps with gates and a few other things. But I'm going to be teaching you how to change a variable and how you can put Boolean variables into use. So here is a very basic Boolean, I would say, gate. We have a button checking our variable here. They're all connected. All the variables are connected because they do have the same name. If they don't have the same name, that means they are not connected. If we go over to my other variable over here, these are not the same variable because it has a different name than these ones. These ones are connected and are storing the same type of data. But here we are checking our variable and checking if it's true. It's like a question. Is Boolean test true or not? If it is, then we are going to set it to be false. And if it isn't, then we're going to set it to be true. And here I have an event. Every variable comes with an event. It outputs every single time the variable changes. So here I'm going to press it and it's set to true because it was false, and now it's set to true. If I press it again, it goes to false. So let's go over that one more time. Whenever we press it, we are checking if the variable is true or not. So we're checking variable, and right now I believe it is false, as the button is saying it's false. So because it's false, it'll go through else and it'll set the variable to be true. Alright, so if we press it again, it went through that. As you saw, that little flash, it went right through as I said. So if we press it again, pressed, we're going to check if it's true or not. Because it is true, it's going to go out to than, and we're going to set it to be false. Press it, you'll see it go like that. And this is just for setting the button text. We're turning the Boolean into a string we can use to display it on the text. Let's go into our second example. Alright, here is our second example. It is just another way of showing how you can change variables. This one is going into itself. So here we have a variable, and this is a not. We went into nots, I believe, in my first tutorial. If you want to go check that out, it is the logic tutorial. But here we have a Boolean going into a not, which I'll go over a not quickly. A not is whatever is inputted, it just outputs the opposite. So if I input true, it's going to output false. Input false, output true. It's just, outputs the opposite. So here I have the Boolean going into the not, and then the not going into the Boolean again. So what that's doing is it's just turning whatever the Boolean is storing into the opposite, and then we're going to set the Boolean to be the opposite. So if we press this, it sets it to be true. So now this variable is true. If we press it again, it is false, because we are inputting whatever is opposite. Right here is where we're inputting it, and that's where you want to input what you want the variable to store. Right there. Alright, so let's do that again. You press it, it's going to go through, and it's going to go into that not, turn it to the opposite, and then it's going to go right back in and set it to whatever the opposite was. Alright, and then we're just setting the button text, of course. Alright, now let's go to our next example. Next example, we're going to be looking at int variables and float variables. Alright, so here is our next example. This is an int variable. I'm going to be showing you how to add and subtract from int and floats and what the differences are. So here we have an int variable, or for longer words is an integer. If you don't know what an integer is a whole number. So it can be 1, 2, 3, 4, 5, so on. But it cannot be 1.5. That is not an integer. We'll go into what that is in a second, but for right now, you just know integers are full numbers. In the game, integers are also shown as green lines. The other one you saw Booleans were red, but this one's green, and that means it is an integer. Alright, so what we're doing here is we're getting the input of we're getting the output of the variable. So here, the output, we're putting it into an add. We're just adding 1 to it. Alright, so the output, whatever it's holding, so let's say it has 0 right now, which it does. We're putting it into an add, we're adding 1 to 0, so 0 adding 1, which is going to be 1, and it's going right back in. So we're just setting the variable, but adding 1 with this add chip. You press it, it adds 1. Press it again, adds 2. Not 2, but you know, it goes up to 2. 3, 4, 5, 6. Let's go over that one more time. Whenever we press it, we are executing these 2 chips, which is just whatever the output is going into the add, and we're just adding 1 to the output, and we're putting it back into the input. So we're just adding 1 and then setting it to whatever it is added 1. So that's how you would add to variables, or whatever you want to do math-wise, add, subtract, or just set it normally. If you want to just set it normally, you can always not have an add and just choose a value here. We're going to set it to be 9. And press it, and whenever I press it, it'll stay 9 because our input here is 9. It is staying 9, and if we ever want to wire it back up to add, it'll go to 10 because it added 1. Alright, now let's go to floats. Here we are on our next example. Here is a float variable. So like I said earlier, integers were any whole number, 1, 2, 3, 4, so on. But here, this is a float variable. It can be a whole number, 1, 2, 3, 4, and 5. It can be those numbers. But a float can also be a decimal. So it can be 1.5, which is what floats are used for. Decimals, not just whole numbers. There are uses to use each one individually. But for right now, we are just going to classify them as decimal. So this one, the floats we use them for decimals, and integers, we use them for whole numbers. Alright, so here we technically have the same thing, but we are subtracting and we are displaying that this is a float. So if we press this button, it'll subtract 0.1, and it will go down to negative 0.1 because we started off at 0. So we're going to repeat what's happening here. Press the button, we're going into that input, and then that output is outputting whatever it's storing. So right now it's storing negative 0.1, and we are subtracting 0.1 to negative 0.1, and then we're putting it right back in. So we're just getting the output, subtracting it, and then putting it right back in to make the variable whatever it is subtracted. Press it again, you'll see it's working, just like that. Alright, on to our next example, which is not really an example. We are looking at some chips, going over them, and then I'll show you some examples about lists. No more variables, we're going into the lists now. Alright, so here we have the list chips we are going to be looking at. We have some list creates, lists subtracts, sums. We're going to be going into them, but here... Alright, here we are at the list chips we're going to be looking at. We have some list creates and some math chips. Don't worry, not too much math is going to be happening here. We just use some of these math chips to get into logic as greater than, less than, equals. We just use some of those, but it doesn't mean you have to be a mathematician to use them. Alright, circuits is not all about math. I would say most of the time you are doing logic, and if there is math you need to do, you can 100% figure it out, or there's probably a way to figure it out using logic. Alright, so don't get scared of these math chips. But we are going to be zooming in here on our list create. What a list create does is we can have a bunch of ports, inputs, and we can have as many as we want. I believe it's up to 15. I don't quote me on that, but there is a max you can do. Maybe 50, I've heard. I've never gone to that max, but there is a max, but you can always combine lists. We'll go into how to combine lists later. But for right now, we have a list of 3 floats. List creates can input and store anything. It can be a color, an integer, a boolean, it can be anything. But today we are working with floats, as most of the chips we have here are math chips. So 3, 8, and 4, we are putting that into a list sum and subtract up here. So 3, 8, and 4, if we add them all together, our list sum is going to output that. What list sum does is it gets the addition of all of the numbers, and it just adds them all together and outputs whatever that is. So 3, 8, and 4 added is 15. So list sum should output 15. As you see on the top of the screen, 15. Alright, and on the bottom here we have list subtract. It does what list sum does, but subtracts. So 3, 8, and 4 all subtracted should equal -9. Alright, so that's what list sum and subtract do. It just adds them all together or subtracts them all together depending on which chip you are using. Our next chip we have here is list max and min. So list max and min, they do the same thing but quite opposites, kind of like list sum and subtract. List max gets the highest number in the list, whatever the biggest number is. So we have 3, 8, and 4 in our list create. So our highest number should be 8. So if we hover over the max, it is, let me zoom out here a little bit, it is 8. Alright, so 3, 8, and 4, it output 8. So for list min, it gets the minimum number or the lowest number. So we had 3, 8, and 4, it is 3. Our lowest number in this list is 3. It is outputting the 3 because that is the lowest number we have in the list. Alright, so that's what those do. And for our next chips, we have list multiply and divide. So what multiply does is the same thing as sum and subtract. So it gets all of the numbers in the list and it multiplies them. This is what 3, 8, and 4 multiplied all together equal. And then for divide, it does the same thing as multiply, but divides all of the numbers in the list. So here in divide, we have 0.09375, which is just all 3, 8, and 4 divided together. Alright. So earlier I said we could have multiple lists combined. So here I have 3, 8, and 4, our first list create, and then down here we have 7, 2, 4, our new list. And here we have a list concat. What list concat does, it combines lists. So let's say I have my 3, 8, and 4 one up here, which I do. It's connected right here. And then I have my 7, 2, 4 one right here. It is connected to list 2. What it does is it will combine them, list 1 on top, list 2 on bottom. So list 1 would be the first list that would show up if you would go in sequential order, and then list 2 would be the second list to show up if you went in sequential order. We'll go into sequential order in a second, and we'll display that list 1 is in fact the first list that is being displayed. But with our list concat, we do have our list min and max again. I have these here to display that our max and minimum have changed because of the numbers we've chosen. So in our first list, we have 3, 8, and 4. Alright, and we've combined it with another list, 7, 2, and 4. We have a new minimum, which should be 2. Because we combined them, we have a brand new list outputting into this list min. Alright, and it should be outputting a 2. As if we go back to our lists here, we have a 3, 8, and 4, but there's no 2 in there. If we go to our second list, we have a 7, 2, and 4. We have a 2. Remember, we are combining the lists with the list concat, and we're putting it into the list min and max. Alright, so it shows we have a 2 for the minimum, but for our maximum, it is still 8, because the second list doesn't have a higher number than 8. So this is showing that we still do have one big list, but they are combined now. So here is one of the most important list I really want you guys to understand this chip here. This is the most used chip. You're most likely going to use this quite a bit once you do start understanding circuits and start using circuits. So here is list get element. So what list get element does is it allows us to get one variable from one data port, whatever you have, color, integer. It allows us to get one of those and use it, because we can't really use the data as a list. We can't really do that. We have to turn it into a one variable thing so we can use it. So in our list we have 3 coming up first, and so index always starts at 0. For a list get element, it always starts at 0, and if we make it go up, so I'm going to configure this to go up 1, it will be 8. Alright, so if we go back up to our list here, let me combine them to make it easier for you guys to look at. Here we have 3, 8, 4, 7, 2, 4. So in the list element, 3 would be 0, 8 would be 1, 4 would be 2, 7 would be 3, 2 would be 4, and 4 would be 5. So let's display that. So let's say we want to get the element of 2. Alright, so 0, 1, 2, 3, 4. So we're going to need index 4 to get 2. Let's go back to our list get element and let's input that 4. Alright, and if we look at the output, it should be our number 2. So that's what a list get element does. It allows us to turn a list into actual usable data. And this is very important. I want you guys to remember that this is what you use to turn a list into stuff you can actually use. Remember that. So on our other last few chips here, list get first index of, this allows us to get the first index of whatever chip it is or data it is. So let's say we want to figure out what index is number, we already know what number 2 is, so let's look at what index number 2 is. Alright, so we're looking for what index is number 2, which we already found out, which is 4. So this should be outputting 4. There it is, 4. So let's do a number we don't know, well, for sure. So for number 2, let's look for number 4. Alright, so this should be index 2. And it's getting the first one. I remember we do have 2 4s. Here we go. But you're saying, what if I have multiple 4s, but I want to get the second one? Well, that's where lists get all indices of. This outputs another list. It gets the list of what indexes that one might show up in. So here, we're going to do one that doesn't show up multiple times, like 8. So 8 here, we have an index of, or a list of 1. And this is outputting whichever index or element 8 is. So let's get our list get element here, turn this to 0, as we only have one list in it. And now if we go over to here, 8 is going to be index 1, which is the second one in our list, technically. But remember, index always starts at 0, so it's 0, 1. Alright, but we do have 4. So let's look for number 4, as we do have multiple shows of 4. So we are going to input 4. And here it is outputting a count of 2, a list of 2. So this is outputting 2 of the indexes that 4 is showing up in. So first 4 shows up in 2, which we know. And then if we do 4 again, so we put it to index 1, it'll output the second one we have, which is 5. That's what list get first index of and list get all indices of do. So here we have list get count. List get count, it just gets the count of the list. So this allows us for logic. I'll show you some logic with this chip later, but for right now, just know that this gets the amount of data ports we have in the list. 4. That's it. It just gets the amount of data we have. And then here, before we go on to our last example, which is just going to be showing you how we can use these type of chips in logic later, we have a for each and random from list. These are some important chips I want you guys to know. I'm not going to be going over them because you need to execute them to show, but I'll explain the best as I can what they do. I would say you might want to figure it, test it on your own first so that you know, but I'm sure you guys can figure this out. If you can't, I'm always here. I can always join you and try and help and explain. I'm always here to help, but let's get into our for each. So for each, we input a list. So let's say we have a list of 70 integers. It just goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to 70. Right? So this for each will go through that list, and every single time it goes into a new port. So it'll do this in one frame. So the list is going in, and within one frame it'll output each data. So it'll say this will execute, this will be 1. It'll execute again, this will be 2. Execute again, 3. It just does all that within one frame, and then it'll be done. That's what it does. It just goes through a list within a frame. Random from list is, I'm pretty sure you guys can guess, it just gets a random data from the list. So let's say we have a bunch of numbers. It'll just choose randomly from those numbers and output it. But you need to execute these, remember. These aren't as important. You hardly use them because these, random from list you might use. But for each does, depending on how big your list is, could take up quite a bit of heat. Remember, I do have a I do have a synced and local tutorial which goes into heat a little bit, not too much, but it does go into heat and why you should be so local. But remember, these chips are very important as well. And let's get into our last example. Here is our last example. This is just showing off a little bit of logic you can do with our list circuits. So I'm going to spawn in 2 basketballs here. And I'm going to put one inside of this trigger volume. Nothing happens. But if I put in another one, amazing, our sound effect goes off. So let's see what is happening here. So on our trigger volume, we are checking every single time an object enters. But before we check that, we have some data ports that are being run. So we are getting the count of the objects inside of that trigger volume. Here we have a list. So we're getting the list, and we're getting how much data is in that list, which right now is none because they've rolled out of the trigger volume. But we are checking if it's greater than 1. So we are checking if there's at least 2 or more objects in this trigger volume. And then we are going to check our if, which remember is a question, if greater than, so is this greater than 1? And if it is, then we are running our sound effect. So let's look at that run again one more time. Let me get these balls. Alright, so I put 1 in, nothing happens. As you can see, the circuits are running. Object entered, it's running, do that list get count and greater than, but nothing's happening because it is not greater than 1. But if we put the other one in, as you can see, it does execute because it is greater than 1. 2. There are 2 balls in it, which is greater than 1. So let's go over that one last time before we are done with circuits for this video. So object entered, the object enters, we are executing our if, which our if is checking is the list of the objects holding more than 1 object. Let's go through that slowly. So we get the objects here. We are getting the count of the objects, so we're just getting the data if there's more than 1 data. So list get count right now is 0 because there are no objects in that. But if there was 1, it would get 1. If there was 2, it'd get 2. Alright, and then we're checking if it's greater than 1. And if it is, then we play the sound effect. If it isn't, that is, it doesn't do anything. Alright, well that was the tutorial. Thank you for watching, and I want to stress this enough. I know sometimes I might speak a little fast because It's hard for me to go a little slow. And I know sometimes it might be confusing when I say, you might be, what does that mean? I'm always here to explain it a little more in the comments if you want to comment. And I'm always happy to join you, try and, teach with you slower, because everyone learns differently. It's okay if you don't understand it fully. Everyone goes at their own pace, and that's why I encourage you guys to go off and try and mess with circuits on your own. That's how I learned circuits. I was just in my dorm. I was like, what does this chip do? Granted, it was Cv1 at the time when I was learning circuits, but it does. Cv2 is not hard, I promise you. It's just you need to put the effort into actually understanding why does this go like this. There's hardly any math, I promise you guys. Sure, you can do circuits that involve quite a bit of math, like noise terrain and angles, but really noise terrain right now is quite useless. It's just a nice showcase. Angles, it can be used for some purposes, but there's 100% always a way to find a logic-based solution. Always. My noise terrain, the one I made a while ago, it was logic-based. You were able to walk around with it generating around you. That was logic-based. There was hardly any math. The only math there was the actual noise terrain. That's it. But I'm sure if you guys put the effort into it and actually go and try and learn by yourself, go and mess around with circuits, I'm sure you guys will start understanding a little bit more. It doesn't mean you're going to become a circuit master within a day. Everyone slowly learns, but I really do encourage you guys to learn on your own. Thank you for watching. If you have any suggestions for what I should learn, or not learn, but teach you guys, please put in the comments. I'm always happy to help you guys. This video was actually suggested by someone a while ago. I was quite busy at college, but I'm getting it out here, and I'm always happy to help you guys.